For today's lesson, you're going to want to have your notes open, and we're going to run through certain problems. So we're going to look at the first page together. I want you to determine the domain and the range for each of the following functions. Remember, our domain describes the x values used by the function. Now, I want you to take careful note here. This function has arrows on the end, so it's going on infinitely in both directions. So when we describe the domain here is going to go from negative infinity to positive infinity. Our range is going to be the same idea. It stretches in both directions infinitely. When we look at question B, we're going to notice there's endpoints. So these endpoints mean that the function stops here. So here, when we look at our x values, our domain is going to stretch from -5 up to +4. Our range, if we box this out, the lowest it goes is -3, and the tallest it grows is +6. Now, when we look at the next piece here, I don't know if you remember this from Algebra 1, but we actually call these piecewise functions because they're broken into two pieces. When we look at the domain for this question, if we box it out, the furthest we go in the x direction is -4. Now I'm going to use a parenthesis here because I'm not actually including -4 for my value. Now if I look along the x-axis, the furthest it goes to the right here is going to be +7. I'm going to include that value because it's a closed circle there. Now you have to mind this here, but because we have an included value of this circle, we're good. When we look at the range, we need to see how low does this function go. So the lowest it's going to go down here is going to be a -2. But again, I'm not actually going to include the 2, so I use a parenthesis because it doesn't actually reach that value. It's an open circle. Same idea if I box it out up top. I'm going to say that the highest it goes is 10, but I'm going to use a parenthesis because it doesn't actually include that value. My next one for D is a little tricky. So when you look along your x-axis, if you try to box this out for yourself, you'd want to say from -2 up to, this guy looks like it's about +7. But what you have to be careful with is there's a value that it never actually reaches. So at this x value of 3, it's never actually reaching the value. So what we do for a situation like that is we say, okay, this is going from -2 up to 3, but it doesn't reach the 3, and then it hops, and it goes from 3 to +7. For my range, the lowest that this function reaches is going to be a -8. I'm going to write this here because it's getting chopped off. And then the tallest that it reaches up here is a +8. But again, open circle never actually touches that value, so I'm going to use a parenthesis. Okay, if we turn the page, this is a little bit of a throwback question. So for this question, we're exploring domain and range. I'm actually going to have you guys put endpoints on this. So this should be an endpoint here, and this should be an endpoint here. Sorry, that didn't really show up very nicely. Let's try it again. Endpoint here, endpoint here. So I want you to take a second and pause the video and think about what our domain and range would be and write it for yourself. Okay. So right now, you've unpaused, which means you've tried to find the domain yourself first. My domain for this function reaches from this edge, this point on the edge here. So if I count 1, 2, 3, 4, it's going from -4 up to 8 on the edge. The range, the lowest that this graph goes, is going to be 1, 2, 3, 4, -4, up to the tallest part that it reaches, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, and again, we're going to use these brackets because we're including the values. If we wanted to solve the equation g of x equals 0, think about the fact that g of x is the same as saying y. So we're looking along the x-axis of where this is equal to 0. So if I ask the question, how many values satisfy that? You have 1, 2, 3, and 4. So if I actually wanted to know what these values are, I would go ahead and I would look them up on my graph. So here, values that solve this equation would be x equals -3, 1, 5, and 3. And I'm just going to, and 7. And I'm just going to do that by counting them, counting boxes. Okay? I'd like you to try part C. You're going to save that for later. And I'm going to run through a couple other questions that I just want to point out to you guys because I think it might be a little hard for you to get a head start. So for number 3, I have this question about boiling water. We know that it's going to boil at 212 degrees Fahrenheit in a room that's at least 65 degrees Fahrenheit. And then I have this table that talks about how the temperature cools of the water, and it's modeling. So H is in hours, that's my input, like my X, and my Y, my output, is temperature in degrees Fahrenheit. So for part A, they're asking us to evaluate T of 2 and T of 6. So basically they're saying what happens when X equals 2 hours. So if we look that up on the table, we would get that the temperature would be 104 degrees Fahrenheit of the water that was left to cool. Same idea for 6. At 6 hours, the temperature of the water would now be 76 degrees Fahrenheit. For question B, think about what they're asking. Now they're saying T of H is 76. So they're telling us something in degrees Fahrenheit. So we need to look that up on the table. So here, this is when my temperature is 76 degrees. So that means the water had been cooling for 4 hours. Now, for the last question, they want to know between which 2 consecutive hours. Remember, the word consecutive just means one after another. Would the temperature be 100 degrees Fahrenheit? Well, remember, my list of temperatures is my outputs. And if I'm looking for things being 100 degrees, we can look at the table and we're going to notice that 100 degrees would have to happen between 104 degrees and 85 degrees. Remember, this is decreasing. So then we're going to say this would happen between 2 hours and 3 hours. So I'm going to show you guys one more question. So I want you to take your packet. This whole next page you're going to do on your own. And then the page after that, you're going to do 8 on your own. I'm going to show you how to do number 9, and that's going to help you with number 10. You're also going to do 11 on your own. So I want you to zone in on number 9. They give us an input-output table, And they also give us the function that goes with that table. So I'm going to just write the function on top of the table. Okay, so I know when I take f of 1, I'm getting 1 as my output based on how I could read the table. So if I put f of 1 in, I get 1 out. If I put f of s in, I get 4 out. If I put f of m in, I get s plus 4 out. Now, they want us to figure out m. So we're going to have to work backwards a little bit. This part, the f of 1 equals 1, isn't really going to help me figure out what my next step is. I'm going to use the fact that I know that if I plug in s for my x value, the output is 4. So I'm going to go to this function and I'm going to say, well, I know f of s equals 4. I also know that when I substitute s in for my x value, it's supposed to equal 4. So everywhere I see an x, I'm going to put an s. And then I'm going to say that equals 4. This will allow me to solve for s. So I'm going to move my 2 to the other side by multiplying by 2 on both sides. And then I get 3s minus 1 equals 8. So now I'm going to isolate the s by adding 1 over and then dividing by 3. Then I know s is 3. So remember, they wanted m, so we're getting closer. That means if s is 3, 3 plus 4 here is 7. So I know when I substitute m into my f function, my output should have been 7. So I'm going to do the same technique I did to solve for s, but now use it to solve for m. So here, I'm going to say 7 equals 3m minus 1 over 2. And again, I'm just plugging m into my function for x. I'm going to multiply both sides by 2. And I'm going to isolate m. So I'm going to add the 1 over to get 15. And then I'm going to say m equals 5. Okay, so for homework tonight, you're going to finish the remainder of this packet. And you're going to make sure that you've checked your answers from last night's homework with the answers that are posted in Google Classroom. And I look forward to seeing you guys either at Extra Help today after school or in class on Thursday.